This section is all about errors versus exception. Now, why? Because bad things happen and we need to know how to handle them. That's really the key to this section is we are handling bad things. By now you've seen me make mistakes, spelling errors, all sorts of syntax errors. Maybe I forgot something and went to compile. Something bad happened and we need to know how to handle that. Before we really dive in, I want to just segue here. An error indicates a serious problem that a reasonable application should not try to catch, meaning we shouldn't even try to handle this. These would be bad things like your hard drive exploding or lightning hitting your house while you're typing, things that we couldn't possibly anticipate with an application, a normal application, I should say. An exception, on the other hand, indicates a condition that a reasonable application might, keyword might, want to catch. This is most things that we've been doing in this course. Pretty much anything you're typing away on the keyboard is something that you might, keyword might, want to catch. There are times you don't want to, and Qt is a great example of that. Qt actually doesn't have a lot of built-in error handling, which brings me to my last point. You notice I said error handling, not exception handling. People use these two terms interchangeably. I am very guilty of this. Almost every developer is very guilty of this. I'll be typing away on the keyboard and you'll see some sort of mistake and I'll say, oh, whoops, we have an error. But in reality, it's an exception. Honestly, if you go up to a group of developers and say, how many exceptions have you caught today? They're just going to look at you and go, well, I had a few errors. That's what I mean by people use them interchangeably. To kind of drive this point home here, I'm going to make an infinite loop. I'm going to say do, and let's go down here and say while, and I'm just going to hit tab, and uh-oh. Notice how we have a syntax issue here. This is completely invalid, and it shouldn't be that way at all. And if I just scroll down, you'll see why. There's a bracket and a bracket and a bracket, but when I mouse over, it says error, expected expression. Is this an error or is this an exception? Well, it's an exception, but they call it an error. Again, don't be confused. All right, now we're just going to say true, and that is our infinite loop. Now, in some languages and frameworks, an infinite loop itself is considered an error or an exception condition. It's not in C++. We can actually do this, and there are no penalties other than your program's just going to run forever. That is, until it's forcibly stopped or it crashes. So let's go ahead and demonstrate a crash. I'm going to say int max equals 44 and int div equals 0. So what we're going to demonstrate here is the infamous division by 0, which will just make your program cry. All right, so we're going to say qinfo, enter a number to divide by or 0 for an issue. Now, if you know anything about math, and yes, I absolutely hate math, but if you know anything about math, really what you're talking about here is division by 0, which you cannot do in math. You can't divide something by nothing. So I'm going to say cin, and we're going to say div. Now, just kind of quick recap, I did have some code already in here. I've got the Qdebug QIO stream, and we're using the namespace std or the standard library, which is why I can do a cin, and we're going to simply read a number here. Now, this is dangerous for a multitude of reasons, but mainly because we are letting the computer cast whatever the user types into an integer, which may not always go as planned. And I can say int answer equals, and we want our max divided by whatever the user just typed in. What do you think is going to happen here? Well, if you think that we're going to have some sort of exception, you are absolutely correct. But I'm going to say possible exception. And then we're just going to qinfo out that answer. Now, looking at our little program, we have no warnings. We can give this a good build. And we can look for compile output, and there's no issues. There's just nothing. It just looks like it's going to work. But under the surface, we've created a subtle problem right here, this line. We are going to say divide that by this, but we're letting the user enter that, which is actually very dangerous because what's going to happen is if they enter garbage, it's automatically going to be 0. Let's go ahead and demonstrate. So I'm going to say 4. So yeah, it's 11. I'm going to say 6. Yep. 8. Now let's say the user goes, oops. Notice what just happened? So 34F is not actually a number. And then it just completely crashed our program. You see this, press enter to close the window. And if we were in a graphical application, it would say like unknown error occurred or something similar to that. That is a good demonstration of how easy it is to break an application. Now, pop quiz, was that an error or was that an exception? What was an exception? It was something that we could have or we might want to catch. Now, because that little demonstration just hinges upon the user input, we might want to catch that. Now, when we say catch, we're going to talk about that in another video real quick here. Catching means we are going to catch it like a baseball and do something with that ball. So what are we talking about in this video? Throwing. Sometimes when you're angry, it's good to just throw things and let it out. But actually, that's not what we're doing. Why do we want to throw things? Well, we want to tell the code exception occurred. What do we mean by this? We know bad things are going to happen. We know we're going to make mistakes, whether we intend for those mistakes to happen or not. I guess we wouldn't, because that's why they're called a mistake. But you know what I mean. Bad things are going to happen. We want to insert ourselves into that uh-oh moment when something bad happens. So we're going to use the throw keyword. We're going to take charge of this. So just to demonstrate here, I'm going to make a simple function. I'm going to say bool do div. And let's go ahead and say int max. And I'm going to just copy and paste just a smidge of code in here to save just a few microseconds of your precious time here. We've seen this before. Now, what's happening here is we've got an integer. We're going to say, hey, enter a number, and then C++ is going to cast this for us, which we've seen is very, very dangerous. We want to make sure we can catch that. But before we do, we want to be able to throw it and know what it is. So think of throwing like throwing a ball. You don't want to just throw a rock at somebody. You want to know what you're throwing. So you're going to throw a ball to them. They may throw it back to you. They may throw it somewhere else. But the point is we are now taking control of the process here. So I'm going to say if value equals 0, then we want to do something here. And I'm going to do the opposite of hello world. I'm going to say goodbye crew world. I'm going to say qinfo 0. Let's just say goodbye world instead of cruel world. I think the world's actually pretty friendly. But so we're going to say goodbye world, the polar opposite of hello world. And now we're going to throw. It's just simply the throw keyword and then some sort of data. You can throw virtually anything. We're just going to do this. We're going to make some quotes. I'm going to say cannot divide by 0. That simple. So we are now taking control of this, and we will know something bad happened, and we can throw this so any code using this could depend on it. We're not going to cover that in this video, but right now we're just micro-focusing on the throw keyword. We're taking control, and we're going to throw out something that makes sense to us. We want to know what happened. And then from here, the rest of the code is, well, exactly what you would expect. I'm just going to, again, copy paste. I got int result, max divided by value. If we get here, this should not be 0, and we should not see that division by 0 problem. And then we can return true. I am not a huge fan of infinite loops, so I'm going to demonstrate how I would do a loop. You can do it any way you want, but this is just how I would do it. Say do, and then I want to go while, and uh-oh, the IDE has betrayed us. There we go. Now you notice up here, our function returns a bool, and we're returning true. So I'm going to say do div. So as long as do div is returning true, then we're good to go. We could say something like if value is 1, go ahead and return false. So let's say we could just say if value equal 1, return false. Just as a demonstration on how you would break out of a loop here. And then you could put some verbiage here about, what to enter and all that. But for now, I'm just going to put a comment that says loop. Let's go ahead and run this. So I'm going to say 5, 4, 3, 2, and of course 1 will now break out of that loop. It doesn't look like anything happened, but you notice it stopped asking us for numbers because you guessed it, we have now broken out of that loop. And we can demonstrate that right here. We're just going to say finish. So let's save, run, demonstrate that again super quick. Enter 1, and we are now finished. We've broken out of that loop. Now let's show the throw keyword in all of its glory. Remember, if we get a 0, then we're going to QInfo out goodbye crew world, and then we're going to throw cannot divide by 0. And let's see what happens here. So I'm going to say 3, 4, and just some garbage, which C++ will cast into a 0, and boom, 0, goodbye crew world, or actually goodbye world, terminate called after throwing an instance of const char pointer. Wait, what? What is this const char point? Where did this come from? That is actually that right there. It's just simply the data type that we threw. So terminate call, this is the operating system saying, hey, we're going to close you down. So it's going to terminate it after we threw something. So now we've injected ourselves into this process. We know something happened and we can send a specific data type out. So you can, in case you're curious, do just about any type of data type. So for example, you could say throw QString and say, nope, I don't know what else to type. We could just put whatever we wanted there. Let's try this again, save run, and let's just actually enter 0. And then see how we are now throwing an instance of QString instead of const char pointer. Point is, we can now take control over the situation and we can decide what to do with this condition. And in this case, we're simply throwing it, meaning we're letting someone else deal with it. In this case, we're letting the operating system deal with that, and the operating system is deciding to terminate our application. In future videos, we're going to look at this a little bit more in depth, and we're going to demonstrate how to catch it. Because if you're going to throw it, you need something to catch it. It's a lot like playing ball. Prepare to be confused. We're talking about catching exceptions. Now, notice this is highlighted. We're not catching errors. We're not going to say, hey, by the way, your hard drive's full or your CPU just died. No, we're going to catch things that we have created, whether we meant to or not. And why? Because, of course, bad things happen, and we want to catch them when they do. So we're using a try catch. We've talked about throwing. Now we're going to catch. And I've got some boilerplate code already here. For example, we've got an int max44. We've got our loop, which is going to go to doDiv. doDiv is going to return true. So if we were to run this now, it would just loop forever and ever and ever. I'm going to slow down here a little bit. I'm going to say row. In the last video, we threw something. So we know this is going to throw something, but we don't know what or where or why. So we need to start bringing that scope down. And when I say scope, I'm not necessarily talking about code scope, just the scope of what could possibly happen. We need to start narrowing that down. This is a lot like playing a detective. So we're going to use what's called the try keyword. And in my version of the IDE, when I type in try, it brings up this autocomplete here of try code block catch parentheses code block, and I'm just going to double click it. And it does this. This is what's called a try catch block. And I'm going to just, for the sake of argument, move that down like this. Now, if you're coming from another language, there is no finally. In other languages, there would be another block of code down here like this. And you would have something like you would try, you would catch any issues, and then you would finally do some cleanup code. Does not exist in C++. I mean, it can be added with other libs and things like that, but just generic old C++ is just simply not there. So we're going to try and catch. So your finally would be anything here. So I'm going to say, instead of no finally, I'm going to say finally here. So now we've narrowed what we're looking for to this. See what I mean by we're getting a little bit more control with every step. We're going to try to do this block of code, and we know that we're going to throw something. So we want a catch to be able to catch what was thrown. A lot like playing ball with a child. You're going to throw it, they're going to catch it. Now, unfortunately, at this stage in the game, we don't know what we're going to catch. So I'm just going to type 3 periods. This is a catch-all. Catch-alls are bad. I'm going to say bad, 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 and I'm going to demonstrate why they're bad. The name implies that it's going to catch everything. So I'm going to just do a little copy and paste wizardry here. I'm going to say Q warning. We know something went wrong, but we don't know what. And I could put a very lengthy explanation or why. And I'm going to just put in our code, which we know has been problematic based off the other videos in this section. We have an integer. We're going to let the user enter a number, and C++ is going to cast that into something. And we know that if they just type in garbage, it's going to be a 0, which of course will really cause issues with this code right here. This would create our division by 0. Now, look at this catch-all. Logic would tell you that should catch it, correct? It actually does not. Let's go ahead and demonstrate. So we're going to save, run, and we're going to say 6 works, 5 works, garbage, and uh-oh, it just crashed our application, and we never got this warning that something went wrong. This is why catch-all is bad. It gives you a false sense that you know what you're doing, and it doesn't actually do what it implies. It's not going to actually catch all. That is super frustrating. So we as the developers have to kind of take charge here. So we can start throwing certain things. So for example, we could say something like, if value equals 0, then we could throw a Q string So there is our little buddy, the throw keyword. Now we're determining when to throw. But we have this nasty little catch-all. Let's go ahead and run this again and watch the catch-all in action. So I'm going to enter some garbage, and now you see our infinite loop just going absolutely ballistic. Oh, that is unfortunate, and it will just go and go and go. So for our catch-all here, we need to actually return something. But you notice what didn't happen. Our program did not crash. It just went into the catch-all. So let's rerun that again without our infinite loop. 7, 6, 5, and enter some garbage. We know something went wrong, but we don't know what. So there's our catch-all in action. This is the other side of catch-all. We don't know what happened. We need to start narrowing that down. So to do that, instead of using a catch-all, we're going to define what we're catching. So now we can have levels of catching. So for example, we can say we want a Q string, E, and in here we can say we caught a Q string. And then we can actually, if we wanted to, print that out. Go ahead, save, run. And we can say 5, 4, 3, and some garbage, and we caught a Q string, cannot divide by 0. So now we're getting more and more granular as things go on, and we can add some other logic in here. So for example, let's say we wanted to get a little more specific, and we could say, if the value is greater than 5, then I want to throw 99. Why? Why not? You can actually do this. You can throw just about anything. The issue is if you're going to throw something, you have to be able to catch it. So I'm going to say int e, and you notice how I'm just doing this randomly anywhere in this catch chain here. It doesn't really matter. As long as you have a catch level in the catch chain, you're good to go. So we caught an int, and that's going to be thrown if we're over 5. So let's say run. And let's say 4, 5, and 6. We caught int 99. So now you can throw different data types and catch those data types as long as you have them defined. That is extremely cool. And you can do things like the standard library is just insanely powerful. I mean, for a standard library, a lot of people take the C++ standard library really for granted. But I'm going to say throw. We're going to throw an STD. Normally, you wouldn't want to throw an STD at somebody. That's how you probably end up in a lawsuit. We're going to throw a runtime error. That's what we're going to do. And I'm not going to go into a lengthy conversation about the STD, different types of errors, but there's a bunch baked in, and you can even make your own. So we're going to say should be greater than 1. What are you doing, you fool? You should know better. But notice what we're doing here is we're throwing a type. Anything after the throw keyword is a type. So now, because we're throwing a specific type, we need to be able to catch that. Now, normally, you don't want to catch an STD. That would be a bad thing. I'm kind of joking because it sounds silly, but normally you don't want to do something like that. But in our case, we're going to do this because we're in code land. We're not out in like the dating world or something like that. So we're going to catch a standard library exception, and we want to catch a const and E. And a lot of people get super confused when they see this const ampersand. So really all we're saying is we don't want to be able to modify this. We don't want to change that in any way, shape, or form. It's going to be a constant. So we're going to say we caught a STD exception here. And notice how now we're saying invalid operands binary expression. That's coming from Q warning, which is saying basically we don't know what to do with this. So if we just go to this, we go what? We can now print out those characters. So if the value is 1, we're going to throw a runtime error. Let's go ahead and demonstrate that. And let's say 3, 2, and 1. We caught a standard exception. Should be greater than 1. The main takeaway here is that bad things happen, but we can control how they happen. So we're doing a little bit of value checking here. We're saying if it's 0, do this. If it's 5, do this. If it's 1, do this. I should say if it's greater than 5, do this. And we can throw different things. We can throw a Q string, an integer, a standard runtime. We can do anything we want, and we can even throw custom classes and custom things. There's really very little you can't do, but another major thing to keep in mind is catch-all does not always catch all. It's very deceiving. Be really, really careful with that. We're going to switch gears for a moment here, and we're going to talk about exception safety. This is something that is a little bit complex and actually goes a little bit out of scope for what we're talking about in this course. I do cover this in the design patterns course pretty much in depth, but we need to have this discussion now so you understand what we're talking about. You've seen that working with errors and exceptions can be really challenging and you can get really complex, but it's up to us as the developer to handle things. And there's different levels or different ways of handling them. Starting at the very bottom, there is a no safety, which means no guarantees are made of any warranty or any kind whatsoever. The code could just explode at any minute. And that's most of the code we write out there, to be brutally honest. And then there's basic safety, also known as a no leak guarantee. This is partial execution of failed operations, can result in side effects, but all invariants are preserved. And there are no resource leaks, including memory leaks, meaning we're going to clean up any pointers or anything like that. We're going to try and do our due diligence for anything that we created in that function gets cleaned up. But then there's a strong safety. This is really complex. It's known as a commit or rollback. Operations can fail, but failed operations are guaranteed to have no side effects. Keywords, no side effects whatsoever, leaving the original values intact. This is pretty challenging to actually implement. And then there is a no throw guarantee, also known as failure transparency. Operations are guaranteed to succeed and satisfy all requirements in situations if it occurs. It will be handled internally and not observed by the clients. This means even if they enter just raw garbage, you're going to figure out what they meant to do and figure it out. And to make matters even worse, this can be on a per code block scenario, not application wide. Each little block of code could be a completely different level. So you really end up with usually a basic safety. Qt does things a little bit differently. One of the things that people often find challenging when they start Qt is there's no built-in error handling. Even when you look at the Qt code, the source code for Qt, you just don't see any of that. Instead, Qt usually favors a bool. They'll just simply return, did it fail or did it succeed? True or false? Did it work? So don't go into the Qt source code and expect to see a lot of, different types of throws and catches. Instead, they're just gone. They're not there. So what do we do instead? Well, typically what you're going to see are, things like this, where you're going to say, okay, if value equals 0, and it's very simple, but it's also very elegant. It takes a lot of the complexity out of things. And then you can just, whatever you want to put in there. In this case, I'm just going to say, okay, cannot be 0. And then you can just take this out to whatever ridiculous level you want to do. So if the value is, say, greater than 5, we can say should be less than 5. And then we could say if it is 1, should be greater than 1. So when you look at this code, it seems, overly simple. We're just got a couple if statements here. We're saying, is it 0? Is it 5? Is it greater than 5? Is it 1? And the code actually will work. Let's go ahead and run this. So I'm just going to say 4, 5 should be less than 5. Okay. So we didn't have any throw, any try catch, none of that. We just simply said, hey, let's do some value checking here. And this is pretty much what most of the Qt code favors. The end result is it will turn a bool. And in a Qt class, usually what they'll do is they'll have a Q string, which will have the error string in that. You'll see that in some of the more advanced classes. Now, pop quiz though, if we were to run this and the user enters garbage, cannot be 0. It didn't crash our application, but where does this fall in these levels? Is it a no-throw guarantee? You saw the application actually stopped functioning. We don't have a commit or rollback, so it didn't roll back to its original state. And we do have some level of safety, so there you go. It's right here at basic. There's a no leak guarantee. We really didn't create anything. We're not leaking any memory. We're not causing any situations that would really cause the operating system to become unstable. That's what I mean by most applications really are, at their core, a basic safety level. Just understand that moving forward, when somebody says their code is perfect or error-proof, they're really usually right here, just a notch above, no safety whatsoever. Inevitably, I'm going to get asked, isn't Qt built on C++? Does that mean Qt can use or cannot use the standard library way of doing things? Absolutely, it can. You can interchange them very, very easily, as we're about to demonstrate. So in this video, we're talking about C++ standard handling. You're going to see this quite a bit in just plain old generic C++ code, and you may even see this in Qt code. Notice I said Qt code, not C++ code. The applications you write with Qt are in C++, but they're Qt. They won't really compile in just normal C++ without Qt and all the libs and all the goodness installed. So let's go ahead and just demonstrate here. I've got our function do division, which has got our little bit of code which has been problematic for us, where we're trusting C++ to see in a value, and if the user enter garbage, of course it's 0, and we get this nasty division by 0 error. And we want to convert this into a little bit safer code. So I'm going to just grab all of this, and you can right click refactor and notice nothing. Oh, it's super frustrating that it doesn't have the option. This is what I mean by a lot of Qt really doesn't help you figure out error handling. It's not really baked into the IDE where most things really are. So to get around that, what I'm going to do here is I'm just going to say try, and we're going to do this try catch block, and it's going to bug me the way those brackets are. So I'm just going to break those out. And then we can just simply take the code, cut it, and we can Paste it right here. The ID smart enough to indent it. Now we can do a little something here. And I'm going to say std, and we want the exception class, and I want to get that class. From here, I'm going to say Q warning. And I see this quite a bit when I'm reviewing somebody else's Qt code. Well, they'll kind of mix and match the standard library in Qt, which is perfectly fine. There's really nothing wrong with this. We're going to return false. So you notice how we have multiple returns. So we're saying basically we're only going to throw a standard library exception. And if we do, we're going to return false. Otherwise, if we get to the end of this try block, we're returning true. There is our loop. So now it is up to us, the developer, you guessed it, to throw things. I'm going to say if value equals 0, then I want to throw std, and I want an invalid argument. Now, the problem when we get into the standard library land is it gets very, very finicky. Someone here is going to say, well, you really shouldn't use invalid argument because it's not an argument. This would be if the maximum was wrong. Ugh, that's frustrating. But we can still use it, even though someone out there is going to say we shouldn't. It's just how it is. It's part of life. So we can grab this, and let's say greater than 5. Just to demonstrate here. And then we can say out of range. I'm not going to give you an exhaustive explanation of every single class that's out there, but there's a lot baked right into the standard library, and you can mix and match them as you want. And let's go ahead and say should be less than 5. From here, it's actually very simple. What we can do is save run and just test this out. Oh, I've got a horrible misspelling there. Go ahead and fix that misspelling real quick, just because it'll bug me if I don't. Now let's save and run. So let's say 4, 5, 6 should be less than 5. This is what I mean by the standard library is very powerful, and yes, you can mix and match. Let's go ahead and put in some garbage and see this cannot divide by 0. There you go. It just works. It's seamless. So Qt is built upon C++. C++ comes with the standard library, and yes, you can mix and match the code as you see fit. Now, there is a huge argument or holy war out there among developers about which one you should be using. So if you use the wrong one, as I have done intentionally in this scenario, expect people to just completely flame you on forums and say, why are you using this one and not that one? But you can see they do basically the same thing. Some of these classes do have some built-in logic, especially if you build your own class inheriting the standard library class. You gotta be a little bit careful, but at their core, they all fundamentally really just let you figure out what happened. I'm going to get asked time and time again, how do we make our own custom handling? I've shown you you can throw your own type of data. You can throw an integer, a QString, your own kind of class. You can throw a cat class if you wanted to. But I constantly get asked time and time again, how do we make our own data type that uses the standard library? So I'm just going to demonstrate that here. We've got the same code we've been working with in this entire section. I've got a try block, a catch block, and we're just catching the standard exception here. So we're going to take this and we're going to inherit it, and we're going to do something with it. Just want to show you that we can do some pretty crazy things. I'm going to say struct. There's a billion different ways of doing this, but we're just going to do it this way just to show you that we can do it. Now we're going to say we want to inherit the public aspects of, you guessed it, exception. From here, we need to do a couple things. We need to say const char pointer description, and this is just me adding it in. And then we can, of course, say grab this and this, and let's say what. So this is our what function, and what is going to const throw. And this gets kind of nuts. And you may be looking at this code going, wait, what? I'm going to just admit it. I Googled this. I don't have this memorized. I rarely use this. I'm just doing this because somebody out there is going to say, how do I do that? And this is what I found on Google. I don't personally use this method. Usually I'll make my own Qt class and I will throw that class, or I'll just throw a Q string or whatever I need to work with. But you can throw virtually anything, as we're demonstrating here. So really what we're doing is we're making a structure, we're inheriting the standard exception, and we're going to const char pointer description. And then we have a function called what, which is going to const throw, and that is going to return a const char pointer, in this case, my issue. Why would you want to do this? Some people just want the complexity in life, but some people want the customization. So we can grab this, we can go here, and now we've got a little bit of surgery to do. We've created basically our own structure, our own little data type here. Really what we've done. And we have some extra functionality we can bake in there. We have that nice little description. So we could do something like this. We could go in here and say, if value equals 1, then, and let's go ahead and say my issue, E, and we're going to go ahead and set that description to user did not read the manual. Just for the sake of argument, say we had some manual out there that said, do not enter 1. And that way, when the customer does what we told them not to in the manual, and it issues this weird error message, we can just go, oh yeah, that's what it means right here. So let's go ahead and demonstrate this. And you actually be surprised in software land how much you see things like that, like user's an idiot, or user didn't read the manual. So I'm gonna say 3, 2, and boom, my issue, user did not read the manual. Now, I'm going to just say it. There really is no de facto way. This really gets into coding standards and convention. Everyone's going to handle this a little bit differently. Some people are going to make their own class. Some people are going to throw raw numbers or strings or something of that nature. Really do what works for you.